so some mechanisms of evolution. These are things that would cause evolution to happen. Natural selection is one that we've just talked about, and it's a very common mechanism of evolution, but it's not the only mechanism of evolution, because evolution is change over time. And so what we see is it's changes in the genetics. So natural selection will cause changes in the genetics, but gene flow will also cause changes in genetics. And the best example of gene flow is migration. So individuals coming into a population or individuals leaving a population will change the genetics of that population. Another one is non-random mating. So in a stable population, a population that's not changing, there's a lot of choices for mates, and it's really kind of random. The individuals can choose who they mate with, but they have a large choice, a large selection to choose from. In non-random mating, we have a situation where maybe there's only one male left in the population, and so the mating is not random. The females only have that male to choose from, and so that male's genetics are what's going to get passed along. And so there's not as much variation in the population that way, and that will change the genetics of the population. Genetic drift is another example of mechanisms of evolution. And so imagine that there's a population living on a cliff top, and then an earthquake comes along and it makes this chasm here. And so you have part of the population living over here, and you have part of the population living over there. Well, this part of the population over long periods of time is going to change differently than this population over here. And so that's considered genetic drift. And then the last one that I'm going to talk about is mutation. And mutation is the most common form of evolution. So mutation in the genetic code causes variation in the population, and that change in variation is going to cause changes over time, which is our definition of evolution. So how do we know that evolution has occurred? Well, we look at allele frequencies, and so we get into a bit of math here when we're looking at these allele frequencies. So I'm going to break this down for you and show you how we would know that there was a change or an evolution from generation 1 to generation 2. And what we would do is we would look at the allele frequencies. So if we have homozygous dominant here, we have capital A, and we have 24 individuals that are that genotype. Well, that means that there are 24 of each A. So we're going to add those together, and we have 48 capital A. In this situation here, we're going to have 12 that are capital A, and we're going to have 12 that are lowercase a, okay? Because they always go in pairs, so we have capital A, lowercase a. So we would add this 12 to that 48, and we would end up with 60 capital A, okay? Now I'm going to skip over here to the lowercase a's, and the homozygous recessive, we're going to have 6 this A and 6 of the little a, because there's 6 individuals total, but they have both the recessive alleles. All right, so we have a total of 12, but we need to add this 12 in here so that we'll have the total alleles for the recessive A. And so that's going to be 24 of the lowercase a. All right, so our total for the alleles is going to be 84. So there are 84 total alleles in this population. And so to find out the frequency of capital A, we're going to take the allele for A and divide it by the total alleles in the population. So 60 divided by 84, we have 71% of these are capital A. Over here, we take the 24 total recessive and we divide it by that 84, because that's our total alleles, and what we end up with is 29% are lowercase a. All right, now if you look at this, 71 plus 29 is going to give us 100%. When we're talking about percentages, that's a good thing because we want to equal out to 100%. So here we have 71% of the dominant allele, we have 29% of the recessive allele. Now let's look at generation 2. Okay, generation 2, we can see a bit of a change right here, but let's go ahead and see what our percentages are now. We're going to have 4 plus 4 for the dominant, so we have 8 dominant alleles there. Here we're going to have 2 of the dominant allele, and we're going to have 2 of the recessive allele. So we're going to add this 2 to the 8, and we have 10 total dominant alleles. Over here we have 12 and 12 recessive, so we have 24 recessive alleles, and we're going to add this 2, so we have 26 total recessive alleles, and we add those two together to see how many alleles we have total, and we have 36 total alleles. So we divide the dominant alleles by the total alleles. 10 divided by 36 is going to give us 28%. And then we divide the 26 by the 36, and that is going to give us 72% of the recessive allele. Now, if we add those together, we have 100%, so we know we're good with our math there. Now we can compare this. We had 71% of the dominant allele, and now we have 28% of the dominant allele in that population. So we have a definite change there. Over here we have 29% of the recessive allele compared to 72% of the recessive allele. So we have a definite change in that population. And what that tells us is that this recessive allele was conferring some type of advantage, and so it became very common in the population. And that's how we know that evolution occurred in that population, because there was a change in the genetic allele frequencies.